All right, let's talk about inverse trig functions. Okay, so the good thing is we're only going to talk about inverse trig functions for sine, cosine, and tangent. We're not going to do it for cosecant, secant, or cotangent. Although we could. So here's trig functions. We've been giving you the measure of an angle, and out comes the ratio. Like we'll say sine of 30 degrees, and you guys know that that is 1/2, right? Yeah, 1/2, right? Okay, so now we're going to go the other way. We're going to use inverse trig functions. The domain is the ratio, and out comes the measure of an angle. Okay, so before we've been using an angle to get a ratio. Now we're going to use a ratio to get an angle. So for example, before we've been saying sine of pi/6 equals 1/2. Now we can say inverse sine of 1/2 equals pi/6, right? Or cosine of pi equals negative 1/2. So pi equals inverse cosine of negative 1. So really, we could think of these as asking a question, right? Cosine of what angle equals negative 1? Or tangent of what angle equals 1? The answer is pi/4. We know that because we know our table of trig values, right? That's how we know. That's why we have to know them. We don't know that trig table. We can't answer these questions that these are asking us. Okay, so let's just think back for a minute to our sine and cosine functions, the graphs of sine and cosine functions. Do these look like they can easily have an inverse? Let's think back to last semester talking about inverses. What has to be true for a function to have an inverse? It has to pass the horizontal line test, right? It has to be 1-to-1. Do these functions pass the horizontal line test? They do not. Okay, so we're going to have to be a little bit clever. Remember that we can restrict domains. Remember when we were thinking about parabolas last semester, and we say, okay, how can we restrict this domain so that this function has an inverse? We're going to do the same thing here. So I want you to think for a minute, what is a way that would make sense to you to restrict the domain of sine of x so that it could have an inverse? What would make sense to you as a way to restrict the domain of cosine of x in a way that it could have an inverse? All right, here's how we do it. Here's the convention. There's an infinite number of ways you could do it, but here's the convention. We restrict the sign to this part of the graph. Okay, so from negative pi halves to pi halves. So from the bottom to the top. And we restrict cosine from here to here, from 0 to pi, from the top to the bottom. Okay, those are the conventions of how we restrict these domains. So it looks like this. Oh, excuse me. Okay, it goes from negative pi halves to pi halves, goes from the bottom to the top. Cosine, we take from here to here. Tangent's like a little bit more obvious. We just take the middle, like the middle of the section that goes from negative pi halves to pi halves, right? And that's the part of tangent that by convention, we restrict the domain to so that it can be to have an inverse, right? And let's look at each of these. All of these pass the horizontal line test, right? They are 1-to-1. For every y value, there's only one x value. For every y value, there's only one x value. Okay. Now, what are the graphs going to look like? So the good news is we're not going to be like graphing these or translating them or transforming them or anything like that. Okay, we just kind of want to basically know what these are going to look like. So sine is the inverse sine graph is this red one, right? From negative, sorry, it's, so sine is the blue, right? Sine is the blue one. So from negative pi halves to pi halves, it looks like this. Inverse sine is the red one. It goes like this. Okay, so it's kind of confusing because I don't have 1 on here anymore. So this would be at -1, and this is +1, right? This, remember, we reflect about this line y equals x, this green line here. So this point moves to here, and this point moves to here. And we can see that the inverse is also the graph of the inverse sine function is also 1 to 1, which we'd expect. So something important. So here's how we write inverse sine, just like we did with inverse general inverse functions. However, for some reason, I don't know why, sometimes we call this the arc sine. It's the exact same thing. There's no difference. It's just a different way of saying the exact same thing. So some calculators have a button that says arc sine. Some calculators have a button that looks like this. Okay, they're the exact same thing. I don't know. And there's really not one that's like more common than the other. They just are two names for the same thing. So let's look at this. The domain, it goes from -1 to 1, and the range is from -pi halves to pi halves, right? Just like the restricted domain was opposite, right? For sine, the domain was -pi halves to pi halves, and the range was -1 to 1, right? So the domain and range switch for inverse functions. Oops. Where are we? Just got lost. Okay. Got in the wrong spot. Let's talk about cosine. So the blue is our restricted the cosine of the restricted domain, right, from 0 to pi. So this one is a little bit harder to imagine. We reflect that about this line y equals x, it looks like this. Okay, so the domain here was 0 to pi, so that's the range. The range was -1 to 1, so that's the domain here from -1 to 1 for inverse cosine or arc cosine. Tangent. So here's our blue line is our tangent going from -pi halves to pi halves. We reflect that. So interestingly, the domain was -pi halves to pi halves. So that's the range of tangent. But the range of tangent was all real numbers, right? It goes all the way down from -infinity to infinity. So that's the domain of our inverse tangent function. That's different. I wanted to go back here for just a minute. So let's think about this in relation to the unit circle. So for our sine function, we are looking at things from -pi halves to pi halves. So that's quadrants 1 and 4. And that kind of makes sense because that scans the whole y-axis or y values, right? From negative. So these two quadrants, any value, any y value is going to give us a sine function, or a sine is going to give us an angle in one of these two quadrants for sine. Tangent is also in these two quadrants from -pi halves to pi halves. Cosine is a little bit different. It's from 0 to pi. So cosine values are going to be we're looking for cosine values in quadrants 1 and 2. Okay, so inverse sine is quadrants 1 and 4. Inverse tangent is 1 and 4. Inverse cosine is quadrants 1 and 2. Okay. All right, so let's just rewrite this. If we know this, given that sine of 5 pi twelfths equals this number, write a relation involving the inverse sine. So here's what it's going to look like. Inverse sine of this thing, 0.965, equals 5 pi twelfths. Okay. All right, that's it for this section, and we'll move on in the next video.